Hi class, good morning. Today we'll discuss compound and reverse curves. Okay, so this is just a continuation of what we have discussed last time about simple curves. Anyway, if you have some questions about this one or the topics that we had before, you can just drop your questions in the inbox. Have a screenshot of it, and then we can tackle and discuss it. Okay, so anyway, if there are some more clarifications, we'll be discussing more about this specific on your questions in the next meeting. So this meeting, our objective is to identify what are those elements of the compound and reverse curves. Okay, so at least we already have the idea of the simple curves. This is just similar to that of the simple curves. Then we are going to try some problems related to compound and reverse curves. This could be helpful, useful for the assessment in the summative assessment, and then similar that you can use in the application for your uh, project, okay, which you have already started. So what is a compound curve? Okay, compound curve is just a combination of two simple curves having different degrees of curvature. So it is used when there is space restrictions. So for example, there's some limitation in terms of space, and then you cannot use all the way the simple curve. Then you can use the compound curves. Formulas established in simple curves apply also in compound curves. As I've said, all the elements, the formulas used in simple curves shall just be applied in your compound curve. Okay, so as you see here, okay, if you look at this one, okay, you have here a compound curve which has, okay, two different simple curves. This is one simple curve, and this is also another simple curve. So the radius in the first curve, you have R1, which is obviously bigger than the second curve. Okay, so if this is the tangent lines, okay, T1 for the first curve, so this is also T1 up to here. Okay, and then from here up to here could also be T2. Okay, so we can see the common chord from B to D is just equal to T1 plus T2. Okay, so that's why it is called as combined, because it's a combination of two curves, and then you have here a common tangent lines. Okay, it's already here. Okay, common tangent line of two simple curves. So formulas, as I said, the same that you're going to use. Okay, you have here the central angle. Okay, I1 is the central angle for the first tangent line, for the first curve, and then I2 also is the intersection angle for the second curve. I1 plus I2 becomes the intersection angle of the compound curves. Okay, so you have here R1, R2, T1, and T2. I said it already. BD, common chord. You have I1, the central angle of the first curve, and then I2 is the central angle of the second. Okay, I is the angle of intersections, or angle of intersection of tangents of the compound curve. Okay, so for example, you have a compound curve. First intersection is 24 degrees, and then the second intersection is 36 degrees. So you have here this one. You always draw the first one, two tangents, right? You have here, and then this one. It happened that the second one is common to the, okay, common to two curves. So this is the I1, and this one is the I2. Okay, given are D1 and D2. D1, what's D1? It is the deflection angle. D1, for example, we exaggerate a curve of stations of 20 meters, and then this is your D. Let's say D1. It's for the first curve. Okay. For example, this is your R1. Okay. Now, what's the question here? You have to compute the length of the common tangent. So what is the length of the common tangent? This one, from A to B, which is just equal to T1 and T2. Okay. For letter B, you're going to compute the station PCC. If PC is at 10, plus 240. You are going to compute PCC. In other words, if you can get the length of curve of the first uh, curve, then you can get PCC, because PCC here is just equal to PC plus length of curve 1. Okay, I hope it's clear. And then compute station PT. Where's PT? This one. Okay. If you have the length of curve 1 and length of curve 2, then you can get PT. Okay, let's answer this one. Okay, so how do you compute R2? This is the formula, right? This is R is it is the same as 3,600 pi d. If we divide 3,600 by pi d, that becomes 1145.916 of d. Okay, this is for, okay, sorry, R2. We compute first the 2. Okay, what is the degree of deflection angle for 2? It's given here 4 degrees. So we can compute the angle of the second radius. This is the second radius. Okay. Okay, for the first radius, the same formula that you are going to use as a formula is this one. Okay. You can use 11.5.916 divide d. The deflection angle for the first curve is 6 degrees. Then you can compute R2 and R1. Okay. What is the formula for T? Take note, the formula of T is R tangent I over 2. Okay? Because the question here, compute the length of the common tangent. The common tangent is this one, A to B. A plus B is the common tangent. A to B, I should say, A to B, which is T1 plus T2. And the formula is this one. So you just need, for example, T1, R1, then I1. Okay? Okay. So the total T, this is T1, and this one is T2. This one is, see, R1. Okay? This one is I1 over 2. See? I1 is 24. Divide 2. I1 over 2 is 24 over 2 is equal to 12. Okay? Similarly here, this one is R2, which we already calculated. Okay? Tangent, this is I over 2. I2 over 2, which is this one, no? Given. 36 over 2, which is equal to 18. So therefore, we can compute the common tangent. This is T1 plus T2. Okay? So we get T, or the common tangent. That is the distance from A going to B. This total length. Okay? So, compute the PCC. What is this station at PCC? We need to get length of curve 1. This is the formula, another formula for the length of curve. Okay? L1 as the length of curve. This is the formula that you can also use. L1 or L over I and then 20 over D. Okay, you can also use this formula. Or L 20 I over D. It's also, we have also another formula with this one, which we introduced earlier, which is relating to the angle of circumference of the curve. If you remember, L is to I, and then 2 pi r circumference of the circle over 360. Okay, this is another formula, which is L, or the length of curve, is equal to r pi r I over 180. This is the other one formula. Anyway, we will provide all the formulas, as I said, during the exam. So in this case, since this given, you can just use this one. Okay, or you may also use this one. Either of the two will come up with with the same answer. So this one is easier. Length of curve 1, L1 or LC1 is the same. I1, it's given, this is 24. So you just okay, the formula, okay, we can have it as like this. L1 or LC1 is the same. 20 I1 over D1. 20 copy. I1 is 24. It's given in the formula. And then over D1. D1, which is also given here, is equal to 6. Okay? So length of curve 1 is equal to 80. Station PCC, as I mentioned, is just station PCC, this one, PCC. Okay, this one, this is station. If you're going to look at here, it is just PC. It is just, okay, it is just station PC plus the length of curve 1. Since we calculated length of curve 1, station PC is given 10 plus 420. So it is just like 10, 420, and 80 is 500. So the station PCC is at 10 plus 500. Okay. How about PT? Okay, the same formula. L2 or length curve 2 is 20 D. Sorry. This is 20 I2 and D2. Substitute. You have 20 I2 is given here in the problem. It's 36. Okay. D2 is also given 4. Then we can get L2 or length of curve for the second curve. So PT, looking at the drawing, this PT is just from PC. You travel here with the length of curve number 2 or L2. Okay, so station at PT plus L2 will give you station PT. This is PCC, I should say. Station PCC plus this 180 will give you station PT. Okay, so here you just have to work on the drawing and then the formula. Okay, another one. For example, you have here the chords of a compound curve from PC here going to PCC, travel over here, and then from PCC to PT. So the chords, what is this chords? Is the straight line from PC to PT or from PC to PCC and PCC to PT. So that straight line 130.6 from PC to PCC, this one, okay? You have 130.6. And then straight line also from PCC to PT, which is 139.16. It's given here. So its common tangent makes an angle of 20 degrees and 36. Okay? Makes an angle. So the common tangent, 20 degrees for the first one, and then 36 for the second one. Now, res see, respectively. So we are starting from PC. So you have here 20 and 36. Now, determine the length of the long chord of the compound curve. Where's the long chord of the compound curve? As I said, it's always the straight line from PC to PT. This is the, okay, this one. This is the straight line. This is the long chord that we are going to answer. Now, how you are going to do that? Okay, if you are going to calculate this one, it is just like now a triangle formed. This one, okay? But you need this angle and this angle, okay? For you to compute this one. There is a formula, okay? We have a formula in trigonometry. In trigonometry, if you have this one, okay? The law of cosine, if this is A, this is A, okay? This is B, and this is C, right? So this one is small b, inclusive angle, and this one's cosine law, okay? If you remember that you have A squared is equal to B squared plus C squared, okay, minus 2 BC cosine of A. Take note, this one and this one are the same. And then this one is just here. Okay, so we have this formula. So in other words, we need to compute this A. If we're going to look back here, this is that angle that we need to calculate. Okay? Okay? So, we need to get first this angle, and we have this triangle. Okay, you have this triangle. Similarly, in the other one, you have also this triangle. Okay, but first, let us compute first what are the uh wait, I'll erase. What are the components? Important components like radius. Okay, the first radius and the second radius. Okay, C is given, and then you have here the first, our PC is going here. So the first angle that you're going to this is radius, right? This is R1, and then this is R1. Okay, it's given here. So we have the formula that will give you this chord between PCC to PC. Okay, this is C. Okay, this is the formula 2R sine I over 2. If you substitute C, which is 130.6, you have this one, right? And then just 2, since we are calculating, we are considering this curve number 1, simple curve number 1, this one simple curve number 2, that, and it became compound curve. So we write here R1 sine, this is I, okay, 20, it's the same with this one, this is I, over 2. So we can compute R1. Similarly, if we're going to consider this R2, you have here this C2. C2 is this one, 139.16. And then is equal to 2R2. Formula, this is formula, okay? 2R2 reduced to, this is I of I2. I2 is 36. So we can compute R1 and R2. Okay? If we can compute R1 and then R1 and then R2, then we can compute our, okay, values, okay, for B and A. This is the angle that we need for us to compute this long chord from PC to PT. So what is A and what is B? If we're going to consider this angle right here, okay, this is 20 degrees, okay, this is the one, and then this is the angle that we need, B. What is this B? And then this is R1, this is also R1, okay, and then this side, this is 130.6. If we are going to calculate R1, we can have this law of cosine. So we have here, this is R1 squared for this one, and then this side is also R1 squared, and then this side, which is 130.6 squared, okay, and then using the formula minus 2 R1 and 130.6, and then cosine of this angle opposite to this which we wanted to get. Using your calculator, you can compute the value of B. B becomes 80 degrees. Okay. Now, how about, that is B. How about A? For A, let's say you have here, okay, this is angle 36 degrees, I2. Okay, this one. Okay. This is 36 degrees. And then at the sides here, R2 and R2. Okay, R2. And then you have here R2. This chord of the second curve, which is equal to 139.16. Okay, we are interested about this angle A. Okay, so we need to compute what is A. So we take this from cosine law, R2 here, squared. Okay, and then two sides, 139 and 16. 139.16 and R2. So you have here R2 squared and 139.16 squared. Okay. Minus 2R. Okay. 2 R2 and 139.16. Just get the product. And then cosine of alpha or A. Cosine of A, which is this one. Okay. That's the cosine of A. So from there, using your calculator again, we can compute A, which is 72 degrees. Now, if I'm going to remove now this one, this triangle, okay, I can get now this distance, which is C, big C, for the compound curve, which is from PT to BC. Okay, this is the triangle now, if I'm going to draw it here. This is now the triangle, okay. Here is A plus B, because you have here A and B. Okay, this side, this is 139.16, and then the other one here is 130.6, and this one is the C that we're going to calculate. Now, using again cosine law, you have C squared, the other one's 130.6, and then 139.16 for the other side, minus 2 times, just copy this one, and then cosine of A plus B, this angle here, okay, A plus B, which happen to be 80 and 72. Okay, using your calculator, you can compute again the question of that long chord from PC to PT, okay, for that compound curve. Okay, now let's proceed to reverse curve. For the reverse curve, as you can see here, okay, these are two curves in opposite sides, okay. So the first chord, let us say you're traveling here, you have this curve, the radius is R1, and then in the opposite side you have R2. This is simple curve number 1 and simple curve also number 2, but in reverse direction. Unlike in the compound, in compound you travel here, you can have here, let us say R1, and then from here you might increase the curve, becomes big, to R2. Okay, in the compound curve, the curves, simple curves are adjacent, whereas in the reverse curve it's opposite. Okay, so let us have this problem. Two parallel tangents, okay, two parallel tangents 12-meter apart are connected by a reverse curve of equal radii or equal radius. It's just like you have here tangents and then tangents like that. They are parallel. So these are parallel, meaning this distance is the same, 12 meters. So if you have here common tangent for, if you have common tangent here for, let us say, that reverse curve, so the circle here will be like this. That, okay, you have here this simple curve. It could be R. According to the problem, they are the same. So the same radii. So in other words, this one is also like that. Oh, sorry. This is also R because they are the same. So in other words, if they are the same, they are parallel. Okay. In other words, this curve L is the same with this one, with this curve. If this is L1, this is also L1. So if this is PC and this is PT, the total length of curve for this reverse curve is just L1 times 2. Okay, for this type of problem, because they are symmetrical, they are the same radius. Okay, now if the length of the curve from PC to PT, if the length of this curve from PC to PT going here is equal to 140 meters, then determine the total length of the curve, reverse curve. Okay, so I have this one. Okay, so you have here If this is I, okay, as I said, this is I over 2 also. Okay, this one is also I over 2. Okay, from this, we form a triangle because according to the problem, from PC to PT is equal to 140 meters. So it just like you have a triangle here. I'm going to put it here. This is I over 2. This hypotenuse is 140. And this is 12 meters because these two tangent lines are parallel, distance 12 meters. And that makes a right angle here. So, from here you have sine of I over 2 is just equal to opposite over hypotenuse, 140. So, I could be computed as this one, 9.834 degrees. You check, okay? You can check. So the question, what is the total length of the curve of the reverse curve? Okay, we have this formula, right? C is equal to 2r sine I over 2. You can see here that C, we consider, okay, this chord of the first one. Anyway, this is the same with the other one here, okay? Just like that. They are the same. Okay, so we just consider this one curve because they are the same in radius. So this is the C, which is 70. We can use this formula. C is equal to 2r sine over 2. We substitute C is equal to 70. It's given here. Okay, this is 70. And then we calculated I, which is 9.34. 2r sine I, this is already I over 2. Okay, or that is 9.834. This is 9.834 over 2 will give you 4.917. So from here, from your calculator, you can compute radius. As I say, the length of curve for this, okay, because they are symmetrical to the same radius, we see it in this drawing, that the total length of curve is just twice of the curve of the, twice of the length of the curve of the first curve. So you can just have, remember that the formula of the length of curve is this one, pi r I over 180. There's also other formula which is L uh, 20i over d. Okay, you can use this one, but we do not have degree of curve. Better to use this one. Okay, so if you have degree of curve, you can use this one. But if you don't have, you can just use this one. You have the, and then here given is radius. Radius, you have already the radius which we calculated. You have I times 2 because, as I said, for this type of problem, it is just two simple curves drawn or designed in opposite direction that makes a reverse curve. The two radius or radii are the same, so that makes this uh, sense 2L. Okay, so substituting to the formula, then we can get the total length of curve of 140.17 meters. I want you to practice solving again this one, and then we have also this worksheet. I'm going to upload this one in the Moodle, and hopefully you can answer this one. If you have some questions regarding our worksheet this week and last week, you can just drop your question to me, okay, via email. Thank you, and see you next next meeting.